Hello, everyone. Good morning. Have you guys seen this video before? This is a flooding in one of the data center in Vodafone facility, bringing down the data center for a couple of days, almost a week, where the customers didn't have a phone service. It costed the company millions of dollars. Above that, customer dissatisfaction. So, my name is Henry Aloysius. I'm a program manager from Failover clustering team. I have Jeff, who is our senior support escalation engineer. We're going to spend today on this session on failover clustering and Hyper-V, especially on a multi-site disaster recovery. Before we go in, raise your hand if your company or you are responsible for an IT service on which your company depends on for 24/7. Excellent. And raise your hand if you're using failover clustering for high availability in your data centers. Awesome. We have the great crowd today. So if you walk down to any data center admin who's running a data center, if you ask them what's the top challenges, he or she would say, what keeps you awake in the night? The top few things comes to my mind are, what if my server goes down? What if there's a power outage which is causing my data center to go down? What if a person intentionally or unintentionally brings down a server, or a natural disaster like flooding or fire or nuclear plant meltdown happening next to your data center? The bad things do happen to the data centers, even for good data centers. With that, from Failover clustering team, we have a product called Failover clustering, which has been shipping from Windows Server Enterprise Edition for the last 13 years. We believe we can understand your pain, and we believe we can propose to use failover clustering to address your DR scenarios. And the remaining of the session, we're going to show you how a failover cluster can help you address your DR disaster recovery scenarios. And if you plan to use your failover clustering, what kind of things you need to keep in mind in terms of deploying failover clusters. One thing I want to keep in mind, just as a disclaimer, this session is about multi-site clustering. We need to make sure that we expect that you have some basic understandings of failover clustering. If you don't, this session may not be the one to help you, but I highly recommend you attend few sessions we have on basics of failover clustering one-on-one. I have towards the end of the session, I have a few slides which talks about few sessions in TechWare, as well as we have a booth and a product demo booth where you can come over and we can definitely answer your questions. Second, we are going to cover a lot of material today. I highly recommend hold on to your questions towards the end of the session. And also, this is high-level recommendations and tips and tricks. So we are not going to details of implementation details and architecture details at this session. The key takeaway, if I've done my job right, there are two things you need to work out. Basically, failover clustering is a great solution for high availability, but it can be also used in disaster recovery scenarios. Number two, we have worked with partners in the last couple of years, and we have built a great ecosystem. And in fact, we're going to show you a demo today with HP's storage replication stack, and Christopher from HP is going to spend a few minutes to show us our real demo using the real hardware. Let's spend a few minutes on what's the agenda. If you walk into a data center, there are three basic fundamental elements: storage, network, compute. These are the fundamental elements on which your data center runs on. So our presentation, for the remaining of the presentation, we are going to focus on these three fundamental elements and see how the failover clustering, or what kind of recommendation you need to keep in mind when you are designing your failover clustering on your data center. Before we go into the recommendation, let's spend few minutes on failover clustering. What's failover clustering? Failover clustering is a high availability platform which ships part of Windows Server Enterprise Edition. This has been part of Windows Server for the last 13 years, starting from NT4 time frame. All it does, it provides you a mechanism in which you can bring together one or more Windows servers, cluster them together, so that it can provide you a hosting environment where you can run your workloads. The workloads could be SQL, Exchange, file server, you name it. But we also, in the recently from Windows 2008 or 2, we also allow you to have Hyper-V workloads. What that means is you can have a virtual VMs hosted on failover clusters. The remainder of the session is primarily going to help you plan your Hyper-V workloads on multi-site clustering. So, failover clustering, the main advantage of failover clustering on a highly available platform is it allows you to detect hardware failures, compute, storage, and network. Cluster will detect failures on hardwares like if a server goes down, or a storage link breaks down, or if a network connectivity breaks down. These are the situations where cluster detects them and provides you a mechanism to move your workload from a failed node to a different node so that the workload can continue to operate. It provides a simplified and automated failover mechanism, works along with a partner ecosystem. We have excellent partner ecosystem where I'm going to show you a few slides, talk about what kind of partner ecosystem we have. In summary, we have a rapid, reliable, manageable HA solution. The question you might ask next is, okay, I have a high available cluster in my data center. What if my data center goes down? Or a flood brings down my data center? Or a fire or power outage in my data center where the whole cluster goes down? That's exactly where the multi-site clustering comes into the picture. Fundamentally, it's nothing but a simple cluster extended over multiple sites. So let's assume you have a site A. Let's assume you have a 3-node cluster running in Atlanta, hosting about 6 workloads. What if the server, the data center, goes down? The cluster, by adding a 2-node in another site, let's assume you have, let's take an Athens, Georgia, which is like about 100 miles from Atlanta. Let's assume you have add 2 more nodes into the cluster, and that node can be a backup site, which can allow you to handle workloads on a primary site going down. The workloads automatically moves. The failover cluster provides you the platform to move the workload from one site, in this case Atlanta, to Athens, Georgia, automatically. It actually provides you the availability, it enhances the overall solution availability, moving from one site to multiple sites. In fact, with this automation, we are providing a DR solution which moves from hours to seconds to minutes. Depending upon your workload, you can do everything in the matter of seconds. Okay, let's focus on the 3 fundamental elements. Let's start with storage. Storage is, as you may all know, it's one of the major investments in your data center. If you look at your data center cost, there's about 60% of your cost goes towards your data storage. Without storage, most of the workloads don't work. Our goal is to talk about what kind of things you need to consider when you are especially talking about multi-site clustering. Let's spend a few minutes on what kind of storage deployment options we have with the failover clustering. As you may know, there's 2 models available, 2 storage paradigms. One is cluster traditional storage, which has been available part of the failover clustering for the last 10, 13 years, which is a share nothing model. In this case, the unit of failover is at the LUN and disk level. You expose a LUN to a cluster. At that point of time, the LUN is exposed as one of the node in the cluster. And that node will be on which you can host workloads. If you have multiple LANs, you can expose each LAN. In this case, you see 3 nodes, you have three LANs exposed to 3 different nodes. When a node fails, the workloads along with the disks moves from one node of the cluster to the next node in the cluster. In this case, the unit of failover at the LAN at the disk level. It's ideal for quick migration scenarios where you want to do if the node fails, we automatically take care of moving the workloads, bring it on the next node in the cluster. There's another paradigm we just introduced in 2008 or 2, which is called cluster shared volume. Cluster shared volume in which multiple nodes in the cluster can concurrently see the disk. You have one disk, one long disk, which is exposed to the cluster. The moment they are exposed as cluster shared volume on all the nodes. In this case, every node owns the disk in terms of doing a read and write operation simultaneously. It's ideal for live migration. If you do a planned failover or if you have a patching scenario, this is an ideal scenario. Storage consideration. Now we know these 2 models. Let's assume you want to deploy this kind of model in a multi-site clustering environment. Let's go with the same model. You have 2 sites, set of servers on site A, set of servers on site B. The bigger challenge is having both sides, the servers on both sides, trying to see the same storage. If you are trying to use fiber channel, it's very difficult to have those, almost impossible to have 2 sites separated around 100 miles apart to see the same, being part of the same SAN network or storage area network. So you end up having 2 set of disks connected to the servers in different sites. Unfortunately, there is no true shared disk here. The question you might ask is, what if the workload on site A moves from one side to the another side? You completely have 2 different sites. They have 2 different data sets. This is where we need to have a solution like data replication mechanism. We at this point of time, the cluster requires you to think about having a data replication stack, which allows you to do a replication from one side to the another side, completely transparent to the cluster infrastructure. The one question keep coming up is, what's the best solution I should use in a replication solution? What's the right solution? If you walk to a storage vendor, almost every storage vendor, almost every backup vendor have a solution for replication. There are synchronous replication, asynchronous replication, host-based replication, array-based replications. The right answer is not very simple. If somebody come and ask me, what's the right replication solution you should use it on a multi-site cluster, the real answer is it depends. It depends on number of factors. We'll start with 2 important factors which you should keep in mind. Before we go and talk to your vendors, these are 2 things you need to sit down with your data center administrators to find out what your goals are. What's your recovery time objectives, RTOs, recovery point objectives. The recovery time objective is the duration of time within which a service must be restored. For example, you have a disaster, how soon you want to bring up your data center back to your previous state. Recovery point objectives, window of time before the disaster during which the data may be lost. In this case, how much data you are willing to, what's your tolerance levels on your data loss. If the data center goes down on 8 o'clock, how back you can go? Are you afford to lose 30 minutes worth of data, or are you willing to afford to lose more than 24 hours worth of data, or do you have a requirement where the data loss is unacceptable? These are the things will determine what kind of replication solution you are going to use in your storage replication platform you're going to use. So there are three-step process. I'm oversimplifying it, but in high level, there are three-step process. You need to select your replication method, whether it's a synchronous or asynchronous. Once you identify, you choose where do you want to have the replication happening. Do you want to happen at the array level? Do you want to happen at the host level? Or you want to have a standalone appliance-based replication solution? Once you identify, there are a few other things you can do it in your data center. Can you go and optimize your WAN with WAN accelerators? Can you do a traffic prioritization? Or can you add a compression on the data going across the sites? So let's spend a few minutes on the synchronous and asynchronous replication. That will give you an idea on what that means. So when you decide your replication stack for your multi-site clustering. If you look at the synchronous replication, you have two storage from the site A on the left-hand side is the one which is the primary storage. At this point of time, the servers on site A is the one servicing the client request. So let's assume the client is trying to the VM is trying to write a I/O to the storage. The primary storage actually replicates immediately when the write comes through, and it replicates to the secondary storage. And it waits for the secondary storage to acknowledge that the write has completed and returned to the secondary storage. If you look at it, every I/O operation goes over the wire to the secondary site and gets an acknowledgement back so that the I/O can be completed. The challenge is right now you are introducing a round trip to a secondary site for every I/O operation. The advantage is you are not going to lose any data. If there's a crash happens, primary and secondary storage are going to be in sync, and your RPO, the recovery point objective, can be as 0, which basically means you don't lose any data on a disaster when a disaster hits your data center. On the other hand, asynchronous. Asynchronous is nothing but when a host receives a write complete response, it basically writes it locally and queues it so that it can be scheduled and it can be sent it over the wire to the secondary site on a time after a scheduled interval. In some of the scheduled interval could be in minutes, it could be in hours. So depending upon your storage replication solution provided by your partners. The advantage here is the I/O, the delay introduced in every I/O write is almost same as a local write, except for the queuing, which is almost negligible in most of the cases. So the disadvantage is if the data center crashes before the queue gets flushed into the other side, you may lose data. That's one of the disadvantages of using asynchronous replication. So let's have a quick comparison. If your recovery point objectives are immediate, you have a high business impact, critical application which cannot tolerate data loss, you should definitely go for a synchronous replication stack. Otherwise, if you have a medium, low business impact, non-critical application which can tolerate data loss, asynchronous could be a better solution. Typically, the synchronous-based applications are 50 kilometers to 300 kilometers. Asynchronous, relatively longer, close to 200 kilometers, about 150 miles. The bandwidth cost is relatively high for the synchronous compared to asynchronous. So if you really look at your data, some situation you need to use synchronous, some situation you may have to use asynchronous. So the answer completely depends on your business requirements. Now let's assume you chose synchronous or asynchronous. The next step is where do you want to have this replication happening? Do you want to happen at the storage, or do you want to happen at the storage array level, or do you want to happen at the host level, or do you want to have a separate storage controller which does the replication for you? Being said that, we have been working for the past few years with a number of storage partners. We work with hardware, We work with software. We also work with network appliances-based solutions. Here are some of the examples where AMC, Hitachi, HP, IBM, NetApp, and Complan, they have a solution stack which works with failover clustering today. In fact, we have a couple of them have a booth in TechEd where you can go and see the real demo using the hardware replication storage stacks. Here are some of the software replication partners. They have a stack which works with failover clustering. Falcon Store, AMC, and DataCore they have an appliance-based solution. There's one thing, there's a caveat. Cluster validation. As you may know, cluster validation is our primary requirement for support. One thing you need to keep in mind, when you are defining your multi-site clustering, the multi-site validation is most probably is not going to pass because every replication solution stack differs in how they implement their, how they expose the storage to the clusters. So this is something you need to keep in mind. If you are using a multi-site clustering, we don't require you to pass the validation if you're talking to Microsoft for support requirements. There's a link. Please take a look. It has some guidances on how you want, how to handle a multi-site clustering, especially with validation. There's another question which comes up. Can I use DFS replication? DFSR is a Microsoft solution which allows you to replicate data on multiple physical storage. Unfortunately, it doesn't work with VM-based or VHD files. The primary reason is DFSR works on Office documents. Primarily, it copies them when the file gets closed. Especially on a Hyper-V-based VHD scenarios, the VHD files are opened once and kept open for a very long period of time. The file never gets closed until the VM is shut down or saved or moved to another node. So if there's a crash happens in between, you will most probably lose all the data returned to the VHD. So we don't recommend using DFSR for your data replication, for your VHD replication on a multi-site clustering scenario. And again, it's a file-based replication. There are a few things happening in SP1. We introduced something called asymmetric storage support. If you remember 2008, when you add a storage to the cluster, the primary requirement is every node in the cluster should see the disk. In SP1, we supported a scenario for asymmetric storage, especially when you have two sites, each site cannot see the other storage. Now, with the SP1, you should be able to add those storage onto the cluster, and you can validate against those subset of the nodes. The other thing is the cluster actually sets a possible owner so that make sure that the workloads which depends on the storage never gets moved to the node where the node cannot see the disk. So there's some smart logic built into the cluster so that we can handle asymmetric storages more intelligently than what we had in Windows 2008. CSV with the replication. We talked about storage requirements primarily from the clustering point of view. CSV with the replicated storage, there's a big challenge. The big challenge is until on a traditional cluster storage, every node at any point of time, only one node can see the disk. With the CSV, you are coming with a new paradigm where multiple nodes can see the storage at the same time, which actually created challenges for our storage partners, especially when they have a replication storage. When some of the storage vendors, they expose volumes on one node, make them read only on the other side, which doesn't work for a number of reasons. So if you're using CSV and if you want to use storage replication, you should definitely talk to your storage vendors. Some of the storage vendors have a solution which works with CSV. For example, HP and EMC and also Data Core, they all have a storage virtualization layer which provides you a mechanism in which they see the storage and provide a virtual storage to the clusters. When the cluster sees the storage, it sees one storage. All the replication, all the site-specific information is completely abstracted from the cluster, so that when it exposed to the cluster, it's exposed as a virtual storage, and it works excellently with clusters. So I would highly recommend, if you are considering a CSP for your multi-site clustering, you should talk to the vendors. And there are definitely a number of solutions which is fully compatible with CSV. With that, let's have a quick summary on what's the storage model you should use. If you're using a traditional cluster storage, it pretty much works with live migration. It works with hardware application, software, and appliance-based application. If you're using a CSV, it's definitely an ideal situation for live migration. Works definitely. We have a solution with hardware application. We haven't seen number of software application solution working with CSV. We have an appliance-based application. You definitely need to work with vendors. Not all the appliance based on hardware-based applications work with CSV. So you should definitely consult your partners to make sure that it works with CSV. With that, I'm going to ask Christopher, he's from HP. He's going to show us a demo of how disaster recovery solution built on top of a HP stack. And we're going to see a demo using the real hardware.
Excellent.
Thank you.
Good morning, everyone. Thank you. Thank you for your time. Thank you, Henry, and also Microsoft. So my name is Christopher Viamonte. I am a storage for virtualization expert, and I work in SWD department and in technical marketing. Heavy on the technical, lighter on the marketing. Today we're going to talk about high availability storage. We're going to leverage one of our products, the P4000 storage technology. Volume, I apologize. Is that any better? Excellent. Thank you for pointing that on out. Good morning, everyone. My name is Christopher Viamonte. We're going to talk about a HP product called the P4000 technology, a highly available SAN that leverages iSCSI, and we're going to show how to extend that high availability across multi-sites, leveraging that technology. So with storage clustering, we have a unique approach with the P4000 technology in that it's a fully scalable clustered technology, just like you would cluster, protect your applications with multiple cluster servers. We bring that to the storage level as well. So the basic building block of the P4000 is basically a storage node. This is based on the x86 platform technology, the ProLiant, but we take our storage software, and each storage node contains multiple disks, controller, CPU, memory, multiple network connections, either 1 gig or 10 gig, in this case for iSCSI. So we don't have a single point of failure. We can survive multiple disk failures through RAID that's local, through the types of disks that you choose. You have IOP or performance characteristics as well as a capacity characteristic of what that storage node can contribute to the overall virtualization space of the SAN. And then high availability and compute power in order to make sure that you're getting that and servicing those IOP requests to servers, or in this particular case, Windows 2008 Hyper-V clustered servers. So we can scale on up the number of nodes within a cluster and basically create that virtualization space and present those volumes on out to your storage area network, or iSCSI SAN. What's also unique about this clustered storage technology is that as you need additional capacity, or maybe additional high availability, or additional performance, you can add additional storage nodes, and in the background we redistribute the information automatically, so it's very easy to manage and basically pay as you grow for your SAN in order to scale on up performance or capacity. As well, volumes are also network rated across that cluster, so in addition to being able to survive single disk failure, we can also survive multiple node failures, and this is what's going to drive our synchronous replication when we talk about that from a multi-site SAN characteristic. Also, this grow on your own terms type of technology basically means that you can add storage nodes or change the size of your volumes on the fly without removing access to that. So again, continuing with your business availability, it's non-disruptive to that environment. The centralized management console is basically a GUI that allows us to manage multi-sites, single sites, basically all of your storage, whatever your storage needs are from a single pane of glass. And we are also able to tier that storage depending upon your requirement needs. In addition to the tiering, if you wanted to move volumes between multiple clusters, you could do that again on the fly without taking down access. So here's an example where we've created a multi-site SAN, and we're writing our volumes that are multiple protected. We see that data blocks get replicated appropriately. In this case, we've got network RAID 10 going across the cluster itself. And that way we can survive multiple disk or multiple storage nodes from going down at the same time. In order to extend that to a multi-site, you're able to protect this by physically separating that synchronous replication to multiple sites. So there's now site awareness in order to give preference to how you're accessing that data locally over non-local means, but also using that same technology of network RAID that we stretch that high availability across a cluster, across multi-sites. So that way we're extending the protection of our CSV volume, the protection of our witness disk across both of those sites, so that whether the servers are at either site or whether you're protecting against a site failure, you're still able to access that data and keep it from disrupting or going offline. So for example, we've gone ahead and we've stretched the data blocks themselves across multiple sites by moving those storage nodes appropriately, giving site awareness to that. We've taken down one site, and we're still able to access our A, B, C, and D on all those volumes. Volumes remain online. That's critical for making sure that high availability exists and continues on, as Henry had talked about earlier, that really the cluster operation, your VMs, your high availability applications are dependent upon the storage being available at both sites. So from this example, we're going to show basically a C7000 enclosure. I've got multiple blades configured in a high availability Windows 2008 R2 Hyper-V cluster. I've got CSV volumes that are exposed. I exposed 3 volumes to my cluster nodes. I've simulated multiple sites. I've got different subnets for that. It's important to note for synchronous replication to work over multiple sites that part of our best practice is to keep network latency down to less than 2 milliseconds. And bandwidth will be dependent upon how much data changes and how much you're writing. Generally, from a per node basis at 1 gig, we see the best practices requirements of being 50 megabytes of bandwidth per second per storage node in the cluster. Or when you leverage 10 gig, it could go up to 200 megabytes per second of bandwidth per storage node in the cluster. Things that we've gone from extending distances. Out of the box, we can support up to 70 kilometers under those conditions with 1 gig. And then we've seen extending those through WAN optimization and other sorts of compression techniques to much further. So in this particular case, what we'll do is we'll show a virtual machine of Windows 7. I'll type some information on in there so that way we can take a look at data that's physically written down to disk. And then we'll take a look at data that's in memory and hasn't been stored down to disk. We'll perform a live migration leveraging the high availability SAN at multiple sites. And then we'll show how that comes back on up and how that's affected and protected, that your virtual machine is still in that same state with a planned live migration. And then also we'll go into the next demo part where we'll actually force a machine down. And rather than going through the onboard administrator and controlling it to shut it down, I've written a little script in order to power off a specific VM running, or a specific machine running Windows 2008 Hyper-V, and we'll see that as well. So the things that we'll see from a high availability standpoint is that, that's all the fun stuff we get to do in marketing, right? So we'll see that our VMs are protected automatically. Because the volumes or the CSV volumes are equal at both sites and you have synchronous replication going on automatically from the storage perspective, that those volumes are presented at the other site just as they were at the first site. So when there is a failure, in this case an unplanned failure, and those VMs start back on up in this particular example to the state of what was on disk. And then we'll power back on the machine and we can show that we've got live migration going back. So if you'll hold on one second, let me switch on over to the demo machine. All right, just for review, I've got two sites, Site A, or Site 1 and Site 2. And what I'll show first is the centralized management console. This is basically our single pane of glass GUI that we can manage our P4000 technology. The P4000 can come in at 4300, 4500, depending upon the size of disk, number of disks. I'm leveraging a P4800, which is actually bringing the storage blade system SAN into the C7000 enclosure. So what I see here is that I've created multiple sites, and within that, those sites are presenting volumes at multiple virtual IPs. Those virtual IPs are basically those iSCSI target portals where we're logging on into those iSCSI volumes. And then I've got multiple Hyper-V clusters that see both of those volumes or all three of those volumes and then use those cluster shared volumes as part of the VM storage space. It's also important to note that I've stored the witness disk on there as well. So from our CSV protected volumes, as we're synchronously replicated, as long as we're in best practice, we can also put that witness or that quorum disk on that replicated storage as well. And I've got 3 volumes that I presented. Of that, I've stored some data of a virtual machine on one of them. So what we see here is basically the Failover Cluster Manager. And we see that there's a Windows 7 virtual machine, and it's currently running on Site A. In fact, I've got it opened up on the desktop here. And what I'd like to do is show you that I'm opening up a text file testing live migration, and I've stored some information in there. Now that's physically written on the disk, written on the SAN. Now what I'd like to do is go ahead and add some information to that, which I'm not going to save so that there's no sleight of hand. And the reason I'm kind of trying to do that is to show you that there's a stateness to what's in memory as to the type of failure and what sort of things that you're protecting when you do a live migration versus an unplanned Godzilla attack. No offense to anyone from Japan. I thought I could do it without mistyping. Very good. All right, so what I've done is I've changed some stateness to that particular file as represented. That's physically in memory on one of the virtual machines that's running on Site A, Site 1A, that Hyper-V server. And what I'm going to do is I'm going to highlight this virtual machine, and within the Failover Cluster Manager, I'm going to select Live Migrate Virtual Machine to another machine, if I can do that. Okay. Let me try to go on over here. It's running Live Migrate to, there we go, Live Migrate to Site 2A. So this would be a live migration, basically, of a live VM or live applications, whatever that you might have on running. In this particular case, it's a VM. And through Failover Cluster Manager, what I'm doing right now is I'm migrating the machine on over. Both machines have access to that cluster shared volume of disk, so we have the stateness of what that information is on disk. And now what we're doing is that for that percentage to complete is really migrating the memory or that stateness of what I just typed on in and the machine as it being on up from that state. So now if we were looking at the other machine, we would see that it was disconnected from that particular VM, so it did close that down. And we'll go back on over to Site 2, and we'll bring up that virtual machine and connect to it. So what we see here is now this virtual machine is running on Site 2, and we've done a successful live migration. And what's also interesting to note is everything from a stateness perspective is still up and going. The information that I had in memory, this is not saved to disk, is still in my text file. I'm still logged in. So we were in that same state of what wasn't pushed down to disk and moved that on over through a live migration process, through a CSV volume, through multiple Hyper-V servers, basically at a different site. These are in different subnets, and we've transferred that on over, so I've simulated different sites. Okay, so now that it's on machine number 2, what I'd like to do is go ahead and do an unplanned failover so that way we can see the difference. I think I've got my script, so that way I do it on server 1. So instead of powering off server 1, I've moved the virtual machine on over to server 2. That's what we've seen. It's running on site 2, machine A. I'm going to power off server 2 and force this through a script. And basically it powers off. Now what we can see here is I will soon lose this site 2 remote desktop session. If I go on over to site 1, we will see that site 2 will be going offline. It's actually machine 3. When I change things on the fly, I'm open to making mistakes. All right, so I'm forcing site 3, server 3, site 2 to go off. I would like to power on back my server 2. That's my domain controller. I love it when things move smoothly. All right, so we see that site 2 is powered off. As expected, everything powered off on site 2. We can no longer communicate to that. Site 1, I see that that's still up and going. And what we should see here is that site 1 is now taking ownership, really, of that virtual machine. But that stuff that I saved or neglected to save to disk, that stuff that I wrote in that stateness of the text file, is not saved down to disk. So hopefully in a second we will have the goodness come back on up. I apologize, I didn't plan for shutting down my domain controller.
Chris, were you doing replication between the disk? I didn't see node 1 and 2 set up as.
Okay. So from a perspective of replication, so what's unique about the P4000 technology is that I create a cluster, and in that cluster now I have a virtualization space. Now on a volume basis, I define volumes as to have a network RAID level, and that's a high availability capability. So with that network RAID level, I'm replicating just by the setting of that volume. I've done that with just by editing the volume or when I create the volume, and that's something I can change on the fly at any time. So by defining multiple sites, I'm putting storage nodes at each site that are then replicating that data as part of a synchronous replication, and that's a configuration option on a per volume basis. So I can do that on some volumes that I really want to protect, up to network RAID +3, 10 + 3. So 4 copies of writes, I can have 4 sets of sites essentially. Or I can even have network RAID 5 and network RAID 6, different characteristics of how I'm storing and protecting that information and what I can survive for a failover standpoint. However, network RAID 5 and network RAID 6 doesn't lend itself to being multi-site capable. So going back to the failover cluster manager, I apologize, I shouldn't have shut down the DC. I'm going to go ahead and power on server 3 as well. It's currently connecting to the cluster. So site 1A is pending. And I apologize, it will come back on up. What we would see essentially is we're going to go back on over to Site 1. We were going to see the VM, start the VM, and we would show that we would have to log on to the VM, so we did not have that stateness because of an unplanned shutdown, a physical shutdown. That VM would be back onto the state from the disk. I'll go ahead and leave this up and go in while the delay is
Sure.
for the domain controller to go back up. But
Let's continue with the session.
excellent.
Yeah,
Thank you.
Thanks, Christopher. Thanks. So let's continue with the session. So we have about 30 minutes. So I just want to cover a lot more stuff in next 25 minutes. Let's focus on network. Network is the next important aspect when you are moving from storage. The next is network. There's two models right now. As you know, 2008 we introduced multi-subnet support. So you can have, when you have two sites, you can have them all in the same subnet, or you can stretch a VLAN between two subnets, or you can have multi-subnets. So each site can be completely in different subnets. So with that, there are a couple of challenges comes with stretching the LAN. Obviously, you have a longer distance introduces latency. When you have latency, there are a couple of things you need to keep in mind. Number two, security. When you're going across multiple sites, you may be going over the network on which you may not have control over. Third, client reconnect logic. When a VM moves from one side to the another site, can the clients connect to the VM after the VM moves to the second side? Stretching the network. So cluster has a mechanism which actually detects the health of a network by doing heartbeating between networks. So it sends a message to each node in the cluster on every available network to make sure the network is up and running. So if you look at here, let's assume you have two networks. One is cross subnet, which is low latency subnet, which is stretched across two sites. The other subnet is cross subnet, which is relatively high latency network. In this case, there are two things you need to keep in mind. If you have a high latency network, you may have a problem if you don't have, if the keep alive messages are not sent and acknowledged on a given time interval, the network may be declared unhealthy, and we would start moving the workloads which is dependent on that particular network. So if you have high latency network, you need to make sure that the cross subnet delay is something more than what default is. By default, we send one heartbeat every second, and by default, 5 heartbeat missing heartbeats are declared is good enough for network to go down. So we need to make sure when you are designing your network, make sure that these variables are appropriately configured for your network configuration. Security over LAN. Cluster configuration is synchronized across all the nodes in the cluster. For example, if you create a virtual machine, all the configuration is stored in the cluster database. When a change happens, the cluster database is updated, it's synchronized. It goes over the wire on a cluster network. By default, this configuration is sent as clear text, but signed. What that means is nobody can tamper with the cluster traffic. But if you are concerned, if you are worried about the data visible to unauthorized user, we highly recommend that you should encrypt your cluster traffic. There's a property of the cluster which you can change it through cluster.exe or using PowerShell. Cluster.exe/property security level 2 basically changes the security level of the cluster traffic from signed to encrypted. Now let's talk about virtual machine IPs on a subnet failover. When a cross subnet failover happens, the virtual machine also goes along with the IP address along with it. So there's two options available. You can use your virtual machines to use DHCP or static IP address. If you use DHCP, the IP address automatically gets updated when the VM moves to the second site. But if you decide to use static IP address inside your virtual machine, you need to make sure that the IP is automatically updated by running a script inside a VM, but we highly recommend using DHCP in those kind of situations. Let's talk about the third problem, which is the client reconnect considerations. When you have nodes in a different dissimilar networks, what happens is when the virtual machine comes online on site A, it registers to the DNS server 1. The DNS server 1 replicates to DNS server 2, depends upon your DNS replication policy. It could be minutes, sometimes it could be 30 minutes to 1 hour. After the replication happens, the client who is dependent on DNS server 2 should be able to get the IP address. What if this VM moves to the site B, which has completely a new IP address, 20.20.20.222? The problem is the IP address gets updated on DNS server 1. It goes through the same replication. It could be about another 15 to 30 minutes. The record gets updated with the new IP address. For this until the new replication happens, the client may be still using the old IP address. So for 30 to 45 minutes, you might not have the VMs accessible to the clients. So this is a challenge. When you have this challenge, there are a couple of recommendations. Number one, try to prefer the local failovers. One way of doing it is use the preferred owners of the cluster. When you define your resources, associate your preferred owner list associated to the VM so that the failover happens locally. So that when a failover happens, the IP address doesn't get changed. The alternate option is stretch the VLAN so that you have one subnet across two sites. The IP address of the VM never changes. The third solution, there are a number of solutions available from our partners. Cisco has a network abstraction layer which allows you to build an IP address based abstraction where you can associate an address with 10.10.111 to 30.30.30. When an IP address moves from, when VM moves from site A to site B, the new IP address gets updated to the intermediate abstraction layer, so that from the client point of view, the IP address hasn't changed. This is one solution we highly recommend if you are going with a third-party solutions. Network requirement for CSV. CSV does not support multi-subnet in 2008 R2. If you want to use CSV, we highly recommend use stretched VLANs. So that's a requirement for 2008. So keep in mind when you are designing your CSV for multi-site clustering. The other important factor is CSV network needs to be same subnet. It doesn't mean that you need to convert all your networks, including your public network, which is used for client connectivity, to be same subnet. You can still have multiple subnet, cross subnets for your public network or client connectivity network. Let's have a quick summary. Multi-subnet and stretched VLAN. Ideal solution would be stretched VLAN. If you have stretched VLAN, all the features you depend on clustering will work seamlessly. When you have multi-subnet, live migration is not going to work, especially if you cannot use it with CSV. Quick migration, fast failover is going to work, but it completely depends on what kind of client resolution solution you're going to use, whether you're going to use third-party network abstraction layer or not. CSV does not work with multi-site. Static IP address in a guest. You need to have some custom scripts running inside your VM to fix your new IP address when a cross subnet happens. It's flexibility and complexity wise, multi-subnet is something which comes out of the box. But keep in mind how completely depends on your business requirements. Let's spend a few minutes on the compute quorum. Last but not least, you need to have enough number of compute nodes in the cluster to be up and running so that a cluster can be up functioning. And satisfy your client requests. So let's spend a few minutes on quorum. Quorum is actually a concept which allows you to have majority of resources to be up and running in the cluster so that cluster can function. Each resource, in our case, a node or a witness, can be a voter. The voter is where they determine what the quorum for the cluster. You associate a vote to a node or a disk or to a file share. With that, you have actually 4 quorum models available today. Disk only, node majority, node and disk majority, and file share witness. Disk only is a 2003 model, which is a legacy model. Node majority and the remaining 4 are introduced in 2008. Replicator disk witness. Christopher talked about it. When a split brain happens, a conflict arises. Who is the right? The witness is the one which breaks the conflict. Witness is the tiebreaker. So the situation is we need to make sure if you're building your replicated, if you're running your witness on a replicated storage, you need to make sure that it works with your witness as a witness. So you need to work primarily with the partners like HP or EMC to see whether they support witness disk on a replicated storage. Let's spend a few minutes on node majority. So we have 2 sites, site A 3 nodes, site B 2 nodes. A network split happens. What happens at this point of time is site A right now has 3 disks, now it has 3 votes. Can I communicate with the majority of the nodes in the cluster? Yes, the site A stays up. What happens is site B goes down because it cannot establish a quorum at this point of time. What happens is site A goes down. We are down, the site A goes down. The client site B should not be able to establish a quorum because you have only 2 nodes in the cluster now. What happens is the cluster goes down completely. This is something we saw in the previous demo where we have 2 node cluster. For some reason, one node cannot come up. It was waiting for the other quorum to be established. So when you reach to that kind of a situation, the only option you have is you need to force quorum. You need to start the cluster with a force quorum switch so that the cluster can be restarted so that it can service your customers. But keep in mind, force quorum has its own mechanism. It ignores the quorum. It basically does not wait for the quorum to be established. So it's running in a special mode. It runs in a special mode until the quorum can be reached.
Can I ask a question on that?
Mm-hmm.
You backwards slide picture. What's the recommended practice to prevent site A from establishing a quorum when there's no one-way connectivity and force quorum?
So wait until this session. I have a few recommendations. If I don't answer, we'll meet after the session. Okay. Forcing quorum is one way to bring down your the site B. We highly recommend using, in this kind of situation, file share witness. File share witness and another quorum model which allows you to identify a witness which is not a cluster node. In this case, let's assume you have 2 nodes in site A, 2 nodes in site B. If site B goes down, typically you would have 2 nodes. Look at the previous example, the site A should go down. By adding a 3rd witness, in this case the file share, what happens is the cluster on site A still stays up. In this case, only site A can see the file share witness, so it will establish a quorum and it will still function as a fully functional cluster. All the workloads in site B will automatically move over into site A. Few special consideration for file share witness. You can choose any simple Windows file server. If you can create a file share, you can make that as a witness and you can run it on a standalone file server, or you can, if you want a highly file server, you feel free to create a file share on another cluster, make that as a file share witness. One warning caveat, make sure the file share witness is not something which is already inside the same cluster. Or If you have a VM, don't put the file share witness inside the VM. Can we hold on till the end? Sorry about that. Node weight. There's another feature we introduced in SP1. If you have 2-node cluster where you don't want to have the backup sites determining the quorum, you can go and explicitly set the weight of the node in this backup site not to participate in the quorum selection. So in this case, you can go and say, I don't want to use node 4 or 3 in backup site to be participating in a quorum selection. If both nodes in the backup site goes down, the primary site will still up and running, because right now the number of nodes needed to be up and running for a cluster to be up and running is number 2 rather than 3. And by changing the quorum changing the node weight, you can do it through cluster.exe. Other thing, let's assume you started a cluster with forced quorum. You have a 4-node cluster. You started a cluster with 3 and 4. Now, the challenge is when the primary site comes back, and it will try to establish a quorum. Part of establishing a quorum, it will go and put its own authoritative, because the cluster is right now running in a special mode where when the node 1 and 2 comes and joins the cluster will go and override the authoritative cluster configuration. So the changes made by node 3 and node 4 will be lost. The recommendation here is when you have started a cluster with a forced quorum, you should make sure when your primary comes back, you need to make sure you should start with the prevent quorum as your startup flag for a cluster service. This will guarantee you that the changes made by node 3 and node 4 while it's running on a forced quorum mode can be maintained. Quick recap. Quorum model recap. We have 4 quorums, 4 quorum model: node and file share majority, node majority, node and disk majority, and disk only majority. If you're planning to use your disk as a witness or disk as the only quorum, then you should we personally don't recommend it as a failover clustering team, but you should definitely work with your partners if you want to go with that route. Our recommendation, if you're going for multi-site clustering, is prefer to use node majority or node and file share majority. Would be the ideal for a multi-site scenarios. We have about 2 minutes, so if you want to have a quick summary, failover clustering has many benefits. You can achieve with one solution, you can get high availability as well as disaster recovery in one solution. There are definitely considerations out there. You have special consideration for storage, network, and compute quorums. You have to work with the storage partner to find the right replication solution. Quorum model is very important. But keep in mind, there are definitely a lot of documentation available in our MSDN. Feel free to log some. There are a few checklists which will help you to decide what's the right solution, right approach you should take. And with that, I'm going to open up for a question. If you have questions, feel free to go, and I'm more than happy to stay after the session. We can answer as many questions as you want. Thank you. Go ahead. Go ahead.
Your suggestion to protect the availability of the file share.
Okay.
How can I ensure the file share is available?
So as I said, the question was, how do I make the file share is highly available? The recommendation is, if you want to have a file share available, have them in a separate cluster and make that file share highly available from a different cluster. Thanks. Sorry, go ahead. So what happens if the file share witness goes down? If the file share witness goes down, you lose 1 vote. If you have enough number of votes, let's assume you have 4-node cluster with the file share witness. If the file share witness goes down, you still have 4 votes out of 5. The cluster should still be up and running. File share witness has 1 vote in the whole cluster.
At some point, you would want to fix that, but it wouldn't take down your entire cluster.
Sure, go ahead. I'm sorry, I can't hear you because the mic is off. Okay. Two sides. Two sands. Uh-huh. So if I can repeat, if I understand your question, you have two sites, there are two separate clusters, and they are working on separate storage. They are replicated, but they are not part of the same cluster.
So the whole part of whether we keep a site regional reload or read write is basically done under the covers by the SAN replication mechanism, whether that's appliance-based, network-based, or host-based. So usually what the vendor will do, if we're moving VMs with it, we'll implement like a resource DLL in that group that when it goes over, will take care of the underlying nuts and bolts to flip that one into read-write mode. Clustering has no idea that that's going on. So. Right. They're offline, but the cluster still knows about them.
So you can point a cluster at offline disks when you write your DR site?
Yes, but you can't bring any resources up and online until they're until the disks are in that mode.
Absolutely.
Yes.
As he said, there
But
are.
Key thing here is you need to work with the vendor to implement this solution because it takes two layers in between us and the cluster to have that work.
So HP has a solution which there's a resource called CLX resource, which actually sits along, make the disk depend on them. So when a resource moves from site 1 to site 2, the CLX resource switches the direction.
Yep.
Then it makes them read write.
Yep.
Exactly.
But you have to go through a very specific process to make sure that the layer in between the cluster and the SAN is in place before you cluster it so it knows that's going on. Okay.
Right. Uh-huh. I'm sorry? Uh-huh. Where is the Cisco box? Uh-huh.